In the Pure 1 course, I go through trig equations and how to solve them. I also go through the cast diagram. Now, before going on to trig for A2, I would very much suggest watching and recapping trig for AS. The reason I say that is because this year trig gets even harder. And you want to be really comfortable with using identities and with using the cast diagram. If you're not comfortable, do as many questions as you can before you go on to it for this year. It's to make sure that you are comfortable, right? It's a step up. Cast diagram for A2 looks the same. The only difference is you're going to be working with radians instead of degrees. So the cast diagram for radians looks something like this. 0, 2 pi. This is just pi. This is pi over 2. This is 3 pi over 2. Okay? How you work with the cast diagram is exactly the same. Solving trig equations is exactly the same. So that being said, can you try and do this question for me, please? Okay. So you want to first take the 3 to the other side. So minus 2. And then tan theta equals minus 2 over 5. So theta is tan minus 1 of minus 2 over 5, which should give you minus 0.3805 radians. Okay, negative numbers are not part of our range. So we want to use the cast diagram, do the reflections, and then take it from there. So drawing the cast diagram, 0, 2 pi, pi over 2, pi, 3 pi over 2. And now we're going to do minus 0.3805, which is going to be somewhere there. Minus 0.3805. Tan reflects straight through. So it's going to go something like that, where this is also 0.3805. Okay? So now we're going to start from 0. We're going to go round till we hit one of the lines. So to work that out, you're going to do pi minus 0.3805, which I'm just going to plug into my calculator now. 2.76109 blah 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 blah. So 2.76 radians. That's one solution. The other solution, you are gonna go from 0, you're gonna go around till you hit the other line, which is 2 pi minus 0.3805. So 5.90 radians. And that's to 3 significant figures. Okay. Have a look at that question for me, please. Cool. So for this one, You want everything to be in terms of sine because your second term, or the second one in that equation, is a sine squared. If you try and convert that to cos squared, you can do it, but it might be a little too complicated. Okay. The first term is cos. The second term is sine squared. So what you can do is you can use your identity to convert that sine squared into cos squared, and then everything is in terms of cos. Remember, the identity was sine squared plus cos squared equals 1, or that's an abbreviation. So that's your actual identity. If we manipulate this, cos squared is the same as sine squared is the same as 1 minus cos squared. That's what we're going to use. So 17 cos theta plus 3, and then the manipulation, 1 minus cos squared equals 13. And now we can expand and move everything to the other side, making the cos squared positive, so it's easier to work with. Like this. And now, putting it into brackets. So 3 cos minus 2 and cos minus 5. Both equal 0. So that means we have two solutions. 2 over 3 equals cos theta, and cos theta equals 5. One of these doesn't work, and that's this one. Doesn't work because remember, in a cos graph, the maximum value for y is 1. So that doesn't work. We're only going to use cos theta equals 2 over 3. Now, when we do cos minus 1 of 2 over 3, theta equals 0.841 0.6866706 radians. Do the cast diagram. And now we draw 0.8410 blah blah blah. It's cos, so it's going to reflect down this way, where this is also 0.8401, right? Oh no, 10, blah 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 blah. Okay, this is our first value. That is the second value, which is 2 pi minus 0.841 blah blah blah, which would give 5.442116637. So your two solutions are 0.84, let's go 841, and 5.44. Both in radians, and both to 3 significant figures. So there you go. That's it. That is how you work with the cast diagram and solve trig equations using radians.